In this video, we're learning about pure substances and mixtures. So we'll cover the difference between pure substances and mixtures, the physical and chemical properties of pure substances, and finally, how to identify substances using their properties. Let's begin by looking at the difference between pure substances and mixtures. A pure substance is something that contains only one type of element or compound, with nothing else mixed in. For instance, pure iron only contains the element iron. Distilled water only contains water molecules, and pure oxygen gas only contains molecules of oxygen. And so these are all examples of pure substances. It's important to note that pure substances cannot be easily changed into anything simpler. We can't separate them without chemical reactions. On the other hand, a mixture is two or more different types of substances that are mixed together in the same place, but most importantly, that are not chemically joined. For example, the air all around us is actually a mixture of gases. It contains oxygen, nitrogen, some water vapor, and a little bit of carbon dioxide, as well as a few other gases too. Another example of a mixture includes seawater, which usually contains water, salt, and maybe even some small grains of sand. One of the useful things about mixtures is that the different substances can be separated using physical methods, which basically means without using chemical reactions. This is because the different substances in each mixture aren't chemically joined together. Next, let's explore the physical and chemical properties of pure substances. Pure substances have characteristic properties that stay constant under specific conditions, and we can use those properties to identify them. These properties can either be physical properties or chemical properties. If we start with physical properties, these can be observed and measured without changing the substance's chemical composition. One important physical property is melting point, which is basically the temperature at which a solid substance melts into a liquid. For example, pure water always melts at exactly 0 degrees under standard pressure. Similarly, the boiling point, which is the temperature at which a liquid turns to gas, is also consistent for pure substances. For instance, water boils at 100 degrees Celsius under standard pressure. And when we say standard pressure, we just mean the normal pressure of our atmosphere at sea level, which we describe as being 1 atmosphere pressure. This is important because pressure can affect melting and boiling points. And this is why water might not boil at exactly 100 degrees Celsius if you're high up in the mountains where the air pressure is lower. Another physical property is density, which is the mass of a substance per unit of volume. So basically how much of a substance there is in a given space. For instance, pure aluminium has a density of 2.7 grams per cubic centimeter, while pure gold has a density of 19.3 grams per cubic centimeter. That's why gold feels so much heavier than aluminium when you hold pieces of the same size, because it's so much denser. Some other physical properties include color, luster, which is basically how shiny something is, hardness, conductivity, which is just how well something conducts heat or electricity, and solubility, which just means how well something dissolves. For example, pure copper is reddish-brown with a metallic luster, is fairly hard, conducts electricity very well, and doesn't dissolve in water. While physical properties can be observed without changing what the substance is, chemical properties describe how a substance reacts with other substances. So in other words, how a substance changes into something new, and if it is reactive, and how fast that reaction happens. Some chemical properties include things like how reactive something is with oxygen, so effectively whether it burns or rusts, how reactive something is with acids, and how reactive something is with water. For example, pure sodium metal has the chemical property of reacting violently with water, and this is a predictable chemical property that helps us to identify sodium. Pure magnesium has the chemical property of burning with a bright white flame when ignited, and this is different from how other metals burn. Pure copper doesn't react with water, but does react slowly with oxygen in the air, forming a greenish layer of copper oxide on its surface over time. Finally then, let's learn about how to identify substances using their properties. Scientists often need to figure out what a mystery substance is, and they do this by testing its properties and comparing them to known values. For example, if you've got a clear liquid and you want to know if it's water, you could test its boiling point. If it boils at exactly 100 degrees Celsius at standard pressure, that's a good indicator it might be water. If you then test its density and find it's exactly 1 gram per cubic centimeter, that's another piece of evidence pointing to water. To be even more certain, you could test some chemical properties too. Pure water has the chemical property of reacting with certain metals like calcium. If you place a small piece of calcium in the liquid and observe it fizzing while producing hydrogen gas, that's additional evidence you're dealing with water. This reaction is a characteristic chemical property of water. By testing multiple different properties, you can build up a profile of the substance and compare it to known substances. Scientists often use a database or handbook of known properties for different substances that they can then match their measurements against. And the more properties you test, the more confident you can be in your identification.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.